So good afternoon and welcome to our webinar today where we're going to look at I think this might be my favorite solution that PTC offers for Creo. I don't know why. I just kind of think that computational flow and dynamics is neat. I am not an expert, but I find this software and this analysis fascinating, especially since we have someone on our staff named Bill Stickney, who is an expert in CFD and FEA. And when I talk to him about these type of solutions, he gets excited. And when somebody's passionate and exciting about something, it makes me excited. So I hope if you're on the webinar today, you're excited to see something really cool. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And leading our overview and demo today of Creo CFD is Andrea Francis, who is a associate solutions consultant and applications engineer with PTC's Virtual Center of Excellence. If you have any questions during the webinar, please type those in the Q&A box. We'll try to answer those as we go. We'll definitely answer them at the end. And without further ado, Andrea, you have control. We can see your screen. Let's go.
Cool. Thanks, Rob. So
Very excited.
let's start. Thanks for the introduction. As Rob said, hello everyone. My name is Andrea. I work as a solutions consultant at PTC, and I'm going to be walking everyone through a Creo Flow analysis. And really, when we talk about computational fluid dynamics in and of itself, it's typically seen as maybe something that requires extensive training or knowledge that engineers in most cases tend to lack. You have to be able to understand what's happening onto your model, run this very complex analysis, and either use a tool to do it or go out to another tool that maybe you don't have. And if you don't have that tool or it's the first time that you're using it, you still have to have some experience on how to properly set up that analysis. And that could be challenging in various different ways. It could be maybe, oh, I don't know what I need to click on here, or what's the workflow? Am I setting this up properly? It could be very time consuming. And depending on the stage of your design process and where you're at from that aspect, it could mean a lot. Maybe if you find any issues, whether it's with the setup or with the results, could lead to many changes that need to happen. It could delay many people. It could cost a lot depending on what it is that you're doing. Oftentimes as well, maybe you're not just relying on CFD analysis in a software. Maybe you're doing physical prototypes, verifying that design, making sure that it works properly. And there's also issues with that. Prototypes themselves, depending on the scale, depending on the complexity of the model that you have, they could be costly. You could spend a lot of time trying to make them on and on, make the changes on them, create your tests, run your analysis on them, and that could cause delay. And you have less time, less budget, and less resources to really spend on actually innovating your product, improving on it, making it the most optimum that it can be to really differentiate you from other competitors that you have out there. And that's why you would need a tool like Creo Flow analysis to help you facilitate all of those problems, maybe. Creo Flow analysis in itself is a computational fluid dynamics tool in Creo to easily simulate your fluid flow. And the goal with it is you're able to take your fluid dynamics capabilities, put them in an easy to use tool right into your CAD environment. You don't have to heavily rely as well on your analysis to be just done in the late stages of your design process. You can very easily incorporate it earlier on in your design, get your results back early, get them back often, get feedback on what's happening, and make changes accordingly. As far as capabilities with the tool itself, it's meant to be used by engineers. You don't have to be a specialist to be able to use it. It's built in a way that works for a Creo user. It's the same user interface. It's very user friendly. You can go in both as an analyst or even as a standard Creo user, as an engineer, and work your magic in there and build any analysis that you want into your overall process of your design. You're able to seamlessly integrate your workflow between your CAD and your CFD. And then with this, you're unifying your analysis in your design process. Your CFD itself is part of the design. It's driving any changes, any judgment calls that you need to make as you're designing and making your product. You have the ability to tell Creo to generate the mesh in your analysis. You don't have to even define it yourself. You still have that ability to go in and define it more, maybe in areas that have more curves or more complex surfaces, or in maybe areas where it's much more of a simple geometry, it's a flat geometry. You don't need as much refinement on there. You can tell Creo, hey, expand our mesh on here and facilitate how the analysis itself is run it much more efficiently than maybe running a full-on finer mesh or just a full coarse mesh as a beginning. You can have a rapid simulation turnaround. You don't have to wait any long hours or even days to get your results from it. You can run the analysis yourself as the engineer and then get your results back into Creo. And these results themselves are highly accurate. There's various ways where you can go in and view them, maybe taking a look at section views, XY plots, viewing ISO surfaces, and really getting insight onto what's happening on the model in a visual way, rather than just looking at a large sum of data that might take hours to be able to comprehend. And that's what the tool allows you to do. And that's what we're going to see with this demonstration today. Let me switch my screen and we can start taking a look at Creo Flow. And for today's demonstration, we're going to be using this snowmobile assembly and specifically targeting the heat exchanger onto that snowmobile. And that's what we're going to be running our flow analysis on it. So once we open up that part, we can start by taking a look at the flow in it. And for us to launch our analysis or trying to set it up, we can navigate into our applications tab into the top of the screen. But for now, let me just remove some of the geometry just to get us started, hide some of those information that we don't want to have, suppress them, and then we can get started directly onto the model. So with Creo Flow, the concept is you're working with a project. In the applications tab, you can launch that Creo Flow analysis application, and then you would be starting with the setup of an individual project. On each model that you're working on, you can choose the type of analysis that you want to run for it. And the setup itself is really straightforward. Here on the top of your screen, you can see we have this ribbon with all of the different tools and functionalities that you have access to. And if it's your first time maybe working with Creo or even setting up a flow analysis and you maybe don't know the correct workflow of what you need to do, you can just follow the sequence of the ribbon itself from left to right to set it up properly. Our first step here is going to be for us to define our fluid domains. We can pick and choose onto the surfaces that we want to include and exclude within our analysis. If maybe you have an internal flow or an external flow system, that's where you would go in and pick and choose onto the surfaces themselves. You even have the capability to split between having fluid components or fluid domain and solid components onto here. Maybe you have some stationary components, rotating or moving components that either you want to include or exclude within that analysis. That's where you're able to set up that definition. And then choosing the material. What type of fluid do I have within my system? Is it water? Is it air? Is it any other type of fluid? Even for solids as well, what the product or the model itself is made out of. And then choosing what type of analysis do I want to do? What is those physics and conditions that I want to take a look at and evaluate? Am I looking at flow, specifically targeting turbulence, maybe cavitation, for heat, maybe radiation, particles, dynamics. It's simply going in and choosing from those models that you have available directly on the ribbon at top. Whatever analysis that you want to run, you can run them all in the same setup of the study that you have. You would be picking and choosing from those modules like what we just did. And you can see in the model tree of the project, it sets all of those up for us. You have different sections of the physics that's going to be used for the study, the domains, that's where you would go in and pick and choose your values and your boundary conditions for those. Do you have maybe a constant density, or there is a temperature on here that you're starting with, a velocity, a pressure at the inlet and outlet. You can even have those be graphed as the analysis runs. So you can take a look at how these values change as you're running the analysis and really tailor the study that you're working on, picking and choosing of, hey, these are my inlet conditions, these are my outlet conditions, this is the flow direction that I have, this is the starting temperature that I have. I have a velocity on here. This is the speed of my fluid as it's going into this component. And this is what it's supposed to be once it goes out of it. These are a lot of the conditions that you can very easily set up directly from within the extension and from within the model tree, as you can see I'm doing right now. If you have a lot of specifications that you can consider as well, you can definitely tailor those for any complex situation that you would have. Maybe this is a model that is comparing to what you have relatively simple. Any condition that you have, whether it's really simple or really complex, you can really go in and tailor those conditions for the study set. Now, after putting in our initial boundary conditions, choosing what type of study we want to run, the next step is for us to set up or generate our mesh. Usually, this is a very important process when you're working with computational fluid dynamics. How do I want to generate my mesh? And how do I want my results? How highly accurate do I want my results to be? You can let the system in Creo generate the mesh for you. If you maybe don't know how to do it, or this is your first time doing it, it simplifies the process for you. You can go in, have it generate, you can pick and choose onto the specifications as well, maybe the grid, the surface, the minimum or maximum number of numbers. And then once it does that, you can generate the study run, have it run any of the information that you would have, simulate the flow that we would have, and this is how it looks like. You can run the study, display the results in a very visual manner. One way to take a look at it is by taking a look at the model, like what you see on the top of the screen. We have our flow in here going in from our inlet all the way to our outlet. And then we have the plots themselves being updated in real time as the study is being run. And you can see all of that as it's happening as well. It gives you that visual aspect of, hey, this is what's happening onto the model and the system itself, how it's running. For the results, you can take a look at various different results that you would have. Maybe you're interested in pressure at a certain point in time, or maybe temperature. These are some color plots that you can work with. You can have section views as well. Maybe we want to look at a particular section onto that model, see how the flow is happening, or if we are concerned about heat with temperature, for example, how that distribution is happening at various points onto the model. Also, something important, taking a look at the ISO surfaces. That's another way to take a look at the temperature distribution that you would have on there. And it really gives you that visual representation of what's going to happen onto the system that you've designed. Maybe you want to take a look at how really high temperatures are going to affect other parts, or maybe they're not meeting the conditions that you have set for that project that you're working on. Maybe you've not met your requirements and need to change something. And that's what's great about working within Creo. You're able to really take a look at this comprehensive data that you have, understand it, even from an engineering point, if the setup itself is done correctly, you can take a look at, oh, I really have a very high temperature on here, and that's not what I want. And then instead of going back and forth between maybe an analysis team and an engineering team, or maybe you're working with a partner to get that analysis be done and get feedback on what's happening, you can do it yourself and then make the changes directly in Creo yourself. It eliminates that barrier that prevents you from working seamlessly. It really reduces the amount of time that you have to wait on results, on feedback, and you can do it simply yourself in a Creo. You can go in and go back and forth between your analysis and your design and make changes. Here, as an example, we have run our analysis. We had a too high a temperature onto that model. I want to make a change to it. I went in here. I'm suppressing some previous parts that I had. Maybe this will help solve that, and it will help diffuse or reduce the high temperature that I initially had. And for me to check in again how this is happening, I'm going to go back into my Creo Flow analysis application, and I don't have to set up my entire analysis again. I can go in and simply update my information on here, and I'll be able to take a look of, oh, I've either added or removed geometry. I need to just make some tweaks as well to the boundary conditions just to accommodate those. I don't have to set up everything from scratch. And even the mesh itself, if maybe now that I've run it, as a general start, I want to refine certain areas, I can do that. And then once I rerun my study, everything is going to update based on those changes that you've made. It makes it really simple for you to integrate your CFD into your design process, drive your decision making as well. As you're taking a look at this, you can really identify any flaws that's happening, resolve any of those earlier on instead of just waiting maybe until a certain point in time or when you're at a certain stage throughout your design to get to making changes and validating that information. You can really optimize that performance much more earlier on and make it function exactly like how you would intend it. You're working right from within Creo, so it's very simple for you to not have to worry about any maybe data translation if you're working with another software or any other CAD system. You don't have to worry about copying geometry, replicating it, defeaturing the model, preparing it, because everything is done right from within the system. The mesh is done onto the model that you have, and you're taking full advantage of all of these capabilities that you would have right from within Creo Flow. And as it's running, you can take a look on it in real time, what's happening. And here, this is taking us a bit more just because we added in additional geometry, but this is the whole workflow of it. You can really work, utilize all of these advantages from a Creo Flow, have that CAD and CFD associativity of I've updated my CAD, my analysis is going to update. I don't have to wait until the updates. I can just make them myself and see the results directly on. And it allows you for a faster simulation and design process to be done. And it's very easy for you to be able to work. Then with the analysis itself that we are running, it's been completed. We can take a look once again at the results that we have, similar to what we had initially. We can maybe are interested into pressures once again, see how they compare to how they were before, or even temperature as well, looking at that distribution and vary those, right? If you maybe have multiple ideas that you want to try out for a singular model, it's very important for you to be able to analyze all of those and not just make judgment calls based on experience or maybe manual calculations and just be satisfied with what just simply works. This is what would differentiate you from maybe other competitors that you have, trying out all of these ideas that you have, getting actual feedback on these and validating them for any of the configurations that you have and getting to your most optimum part. And that's what it's all about, right? You can use your CFD, use it in a tool that allows you to work seamlessly into your CAD system. You can work towards this analysis-driven design process and run your different studies really early on in your process. It really helps shape your ideas very early on, and you can validate your work as you're going about it. You can reduce a lot of time, a lot of money as well as you're working if you're using prototypes, if you're relying on another team or a partner to run your analysis for you. You have multiple iterations that you want to run very earlier on, but you're worried about having to wait and waste time for that. You don't have to do all of that because you yourself can be empowered to do that right from within Creo Flow analysis and work towards getting the most innovative product, but also with the highest quality maintained. You're not just innovating for the sake of innovating. You're innovating with the goal of I'm achieving my requirements, I'm achieving my objective, and still maintaining the quality of the product that I have. And that's what Creo Flow analysis is all about. And that ends the presentation for the day. Any questions that we have at all by any chance?
Awesome. No questions, very thorough. Very, very direct and to the point. I like the way you explained everything. Is very, I think, simplistic and very easy to understand that this, how this tool can help people who are not CFD experts early on in the design stage, design for form and design for function, not just form and fit. And then it reduces the rework, makes things a lot easier. You get a better product. There's a whole ton of benefits to it. So great job, Andrea. I appreciate it. So
thank you.
Thank you. So thanks to everyone for being on. I'm going to have the recording uploaded to our YouTube page and sent out to all who registered tomorrow, so you can view it at your leisure. But if you have any questions, feel free to respond to the email that I sent regarding this webinar, or you can contact us at info@3hti.com. We can do a custom demo on Creo Flow or any other Creo extension or Creo package, as well as Windchill. So anything that meets your PTC needs, feel free to contact us and we can get you some more detail on it. Thanks again, everybody, and enjoy the rest of your week. We appreciate it. Take care.